Welcome to the 42nd lecture. We are studying average or active power, and there is a small recap. The active or average power measured in watts is 1/2 times or 0.5 times the magnitude of voltage, the magnitude of current times the cosecant of angle between the voltage and current. If we want to find power absorbed in a resistor, we'll have to first find the voltage drop across it. The magnitude of this would be Vm and theta would be theta sub V, and then we have to compute current through it, and we'll write it at Im at an angle of theta I. So first we have to compute this voltage and this current. Only then we can find this power absorbed in a circuit. If you want to find out the power absorbed or produced in a source, maybe in this source, then this is always given. We have to find the current through it and the angle of the current, and then we can plug these values in this expression to find the power absorbed or produced by this source. So there was a little confusion in last lecture that which V and which I we should use to compute this power. So now I think now it's clear that the voltage and the current, the voltage across and the current through the component for which we are finding power is plugged in here. So in this example we'll make this concept a bit more clear. We want to find the power dissipated in this 2 ohm resistor, or power absorbed in this 2 ohm resistor, and in this 4 ohm resistor. We already know that the active power or average power that we are studying here, we call it P, is 0 in inductors and capacitors. In our upcoming lectures we'll see we have a different power we call reactive power that is non-zero for inductors and capacitors. So for this lecture, this P, average or active power through this inductors and capacitors, is always 0. However, the power absorbed in this 2 ohm resistor and in this 4 ohm resistor, if we add these two powers together, that will be the power produced by this 12 at an angle of 60 degrees voltage source. So the power produced by this source would be equal to the power dissipated in 2 ohm resistor and in 4 ohm resistor. This we can verify at the end of this lecture. So let's find power absorbed in 2 ohm resistor first. For that we want to know the voltage across it, V across 2 ohm, and we must know the current through this 2 ohm resistor, and then we can plug those in the standard formula P is equal to 1/2 Vm Im cos of that, and we can find power in watts. So for the purpose of computing this voltage across this 2 ohm resistor, we must know this voltage. Let's call this voltage as capital V. So on the upper end of this 2 ohm resistor is connected with a 12 at an angle of 60 degrees source, and the lower end is at 12 volts. So voltage drop across it would be 12 at an angle of 60 minus V. That will the voltage drop across this 2 ohm resistor. The voltage on its one end minus the voltage on the other end. This 12 at an angle of 60 volts would be higher compared to this, we know, because it's the only source and it is driving current through these components. But for the sake of finding this V, we need to apply nodal analysis, and for that we assume that all currents are moving away from the node. So let's apply nodal analysis to find V first, because we don't know V and we cannot find the voltage drop across 2 ohm resistor. So first we'll find V, and then we can find voltage drop across 2 ohm resistor. So nodal analysis gives us, we write KCL, Kirchhoff's current law equation for this node, V minus 12 at an angle of 60 divided by 2 plus the current in this branch 4 ohm plus the current in this branch minus J4 is equal to 0. We know that it's all ohms. These are all ohms. In the numerator we have all ohms. So this is an equation, we can solve it. I have solved my nodes, multiply the whole equation by 4 and then we find V and we convert it into polar form. It comes out to be 7.6 at an angle of 41.5 degrees. So this V can be used to find voltage drop across this 2 ohm resistor. 12 at an angle of 60 minus 7.6 at an angle of 41.5 degrees. So to subtract these two numbers, we have to first both numbers into the rectangular representation, we then subtract and then we come back to the polar form. V2 ohm comes out to be, there is some work which is left as a homework for students, and at the end it comes out to be 5.4 at an angle of 86.7 volts. So we are here, V2 ohms. Right, and then to find power through this 2 ohm resistor, we have to do what? Find current through it. Finding current through this 2 ohm resistor, I2 ohms, is the voltage drop across it divided by its value 2. So 5.4 divided is 2.7 at an angle of 86.7 degrees. So now we have computed everything required to compute power absorbed in this 2 ohm resistor. 1 by 2, the magnitude of the voltage 5.4, the magnitude of the current through it 2.7 times cos of angle of voltage minus angle of current, since they are the same, they are always the same for resistors. Cos of 0 is of 1. So power dissipated comes out to be, or power absorbed in 2 ohms resistor is 7.2 watts. The next is that we want to find power absorbed in this 4 ohm resistor. For that we have to do the same thing, find the voltage drop across it. Since this is V, this is ground, the voltage drop across 4 ohm resistor is the same as V, and we have computed V to be 7.6. As a result of applying nodal analysis, we computed V 7.6 at an angle of 41.5 volts. And finding current is straightforward. I through 4 ohm, this current would be the V divided by 4, according to Ohm's law, V divided by 4. So 7.6 at an angle of 41.5 divided by 4 amperes. So 7.6 divided by 4, 1.9 at an angle of 41.54 amperes. Sorry, I through 4 ohms is this current. So we have computed this voltage and this current. So we are now all set to find the power absorbed in this resistor. 7.6 times 1.9, the magnitude of voltage across it, the magnitude of current flowing through it, times cos of difference of angles between the two, which is 0, Cos of 0 is of 1, and we compute it to be luckily the same value, 7.2 watt, which we computed for 4 ohm. It's only by chance that the power dissipated is the same, the power absorbed is the same. Now there is a small homework for students. What the homework is that you have to homework for students is that they are required to verify that the power produced in the only source in the circuit is the same as the sum of power absorbed in 2 ohm resistor, 4 ohm resistor, and minus J4 ohm. A capacitor, the capacitor with capacitive reactance minus J4 ohm. You will see that the power absorbed in this minus J4 ohm capacitive reactance would be 0. You can verify it. So it's a homework to verify this expression, and you'll see that the right hand side of this equation should be equal to the left hand side of the equation. In our upcoming lectures, we will see reactive power for AC circuits. Thank you. See.